Alright, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. So, for you guys to know, there's about like 155 participants for today's class, and I hope you all can enjoy about what we are going to learn right now. And we are basically going to focus on ROS, which is the Robot Operating System. And my name is Fatima. I will be your course coordinator for today. Alright. And if you guys have any questions or any inquiries regarding this class, you can just use the text box to ask the question, and my team will help me to answer the question, while I will also try to answer the question from time to time. Alright. Alright. So you guys are ready to start the class? Alright, so I will go on and start the class first, alright? Okay, a bit louder, alright, okay. Alright, so okay, now we are on the slides. Before that, before I start the class, I would like to tell you that for those who have not registered yet, I highly encourage for you guys to register, because at the end of the class, maybe after the class or as soon as possible, I'll give you all the slides and also some a booklet for your self-learning guidance, so that you can have your own practical self-learning. I'll give all you the websites, the links for you to study by yourself. So I highly encourage for you guys to register through our website. Okay, alright, ready guys? Okay, today we will focus on the robot operating system, which is ROS. Basically, ROS is widely used for the people who are trying to create or trying to develop a very highly multifunctional robot. Okay, so there's a lot of benefits that we're going to go through later on about ROS. So right. So this is a little bit introduction about myself. I will be your course coordinator for today. My name is Fatima, and I'm a robotics engineer at Robopreneur, Sendirian Berhad. And I have been experiencing in ROS for about 1 year. And those are basically the projects that I have been involved in ROS. So the first one is the vision-based object tracking by using OpenCV library for unmanned aerial vehicle, which is the drone, by using ROS, Robot Operating System. And the second one is about the SLAM, which is the simultaneous localization and mapping by using ROS for the unmanned ground vehicle. Alright, so if you guys have any questions, my team will also help you to answer through the chat box. Don't worry. Okay. So what you guys will learn from this free online ROS training. So this training is focusing on those people who does not have any basics in ROS. It's okay if you do not have any basics, or you are very eager to learn about ROS. So this is the right platform for you to come and learn about ROS. So the first thing that we are going to go through is the introduction to ROS, and after that we'll go on to the key concepts that are being used in ROS, so that we can see on how exactly ROS work, on how exactly we want to execute ROS. And third, this is more onto practical, or more onto the visualization on how ROS works. And then we will go through onto the example of application that we can use by using ROS. And the last one, we will go on to the debugging and visualization tools. This is very useful. I would like to show you guys on how you can actually visualize or simulate a real robot by using the tools that are available in ROS. It is in real time. Okay, it's very useful for you guys to learn this. Alright. So before we start, for those who are interested in, like, we have provide hands-on training. So if you guys are interested to come and join us, you can register at our website. And usually it is for 2 days hands-on training, and it is located at our futurized building at Sabajaya. And for ROS, only for ROS, our audience are targeted from 18 years old and above. But if you guys are interested to join other classes, other hands-on training classes, we have this, okay, the first one, we have the Kickstart to ROS development. This is the hands-on training on ROS. And then we also have the Arduino and Design Road of Maker. This is focusing on the primary school students, the secondary school students, and it is basically an introduction to Arduino, and there is also some hands-on application on how we can use the Arduino to execute some applications in our daily life. So it is very good if if you guys are like teachers or you are trying to do some projects in Arduino. It is very good for you guys to join these classes. And we also have hands-on training on Python 3, which is focusing on the basic training on Python. And we also have some introduction on how you want to apply it in data analysis. So if you guys are interested, for now, there is not like a specific date for it yet, but you guys can go to our website to keep updating about the trainings that we have. And the last one, we also have the PCB fabrication training, which is the printed circuit board training. So if you guys are interested, you can come and join us. Alright, so you guys are ready? So we will go on to the introduction to ROS, Robot Operating System. So as you guys can see from the picture of the slides, that is Adam Robot, which is a robot that is being developed and designed by Robopreneur. And this robot also can move and talk, and it is basically developed also by using ROS. Okay, that's just only like one example. Alright. So right now we'll go on to what is ROS. So basically, I would like you guys to think about ROS. It is not like the software programming that you guys usually do, for example, in Python, in C++ programming, in JavaScript, and etc. It does not work that way. So I would like you guys to think of it not as a software programming and not as a hardware. It is basically, ROS is like a middleware that integrates between the hardware and also the software. So it is a middleware that actually helps you guys to allow different types of robotic software such as C++, Python, JavaScript, MATLAB, and etc. All of those software programmings to actually communicate and transfer data among each other. Alright. And the second one is that there is no need for you to reinvent the language wheel. So what it means is that when you guys, for example, want to build a very high complicated robot, as you guys can see, the Boston Dynamics robot, I will show you a video later. So you guys can see it is very complex, very robust, multi-application. So if you guys think about it, it cannot be only built by one engineer. It must consist of several engineers, like robotics engineers, software engineers, and etc. So for example, if the first engineer is very comfortable in Python and the second engineer is very comfortable in C++, there is no need for you guys to actually convert one language to another. So you guys can stick with what software languages that you are comfortable with, and then you can use ROS to integrate, for example, many types or maybe both of the languages. So that is where ROS is applied. That is where ROS is you guys on how to develop such a robust robot, for example. So as you can see, I will give you guys an example. Okay, which is the Boston Dynamics robot. Alright. Okay, you guys can see this. Right. This robot is very complicated. It acts like a human being that can do parkour. Okay. So basically, it involves a lot of programming, a lot of engineers. So by using ROS, you could actually build this type of robot. It is you to build this kind of robot to actually move in such a very complex way. Right. Okay. So you guys can just search about the Boston Dynamics robots, and you can see many types of other robots that they built by using ROS. So it is highly encouraged for you guys to see the videos on YouTube. Right. So besides that, we will go on to our class today. It also is for you guys to build the robots by sharing the information and data needed, as like I have given an example before. And the last one is that the supported platform that we can use to execute ROS is the first one is the Linux operating system, Mac OS, and also partial support for Windows. Okay, for the partial supports for Windows, I don't really recommend for you guys to use that because if you use the partial support, you could only use the terminal to execute ROS. So you could not actually see the interface, the GUI interface, the real visualization of on how you execute the ROS. So I highly recommend you guys to have a dual boot operating system in your laptop, for example. So I will give you guys the link on how to actually do a dual boot operating system later on in a booklet. So you guys can see it is better for you guys to use Linux as your operating system to execute ROS. Alright. So we'll go on to the ROS philosophy. Okay. So the first philosophy that we are going to see it is that it is peer-to-peer, which means that all of the individual programs that you use to communicate between one another is defined over one specific API. For example, is the messengers and the services. We will go on to the concepts later on. We will see on what is exactly messages are and what is exactly services are later on. So the second one, it is distributed, which means that it can run on multiple computers, multiple laptops by using the wireless network. And the third one is multilingual, which means that, as I said before, it can be executed by using Python, by using C++, JavaScript, MATLAB, anything of the software programming that you are comfortable with. And the fourth one is lightweight. Alright. The lightweight means that, for example, if you want to do the visualization, so you're going to use the, for example, the Gazebo library and also the RVS library. So if you're using ROS, it is actually lightweight, means that it only consists a ROS wrapper to execute the software. So it does not use quite a big memory to execute ROS. So it is very useful. And the last one, this is the most applicable for all of us, which is it is free and open source. Anyone can install ROS, anyone can learn ROS, anyone can actually explore ROS. So it is very good for you guys to actually see and explore on how actually we are going to use ROS. Alright. So okay, the first one is why we're going to use ROS. Alright. The first one is it is the hardware abstraction, which means that, for example, if you have a real robot in the real world, for example, and then you want to like simulate or visualize the movement of the robot, for example, the motor of the robot in real time. So ROS could actually do that. For example, if you're actually moving the robot forward, and then at the same time, you could actually visualize the movement of the robot while it is moving forward. So I will give you guys for an example later. And the second one is that it can launch multiple modules whenever you want to. So there is no need for you to write your own custom bash script anymore. You could use ROS launch. Alright. So we could see, for example, alright, this is the cat keyword space. So for every ROS task that you're going to execute, you have to use the cat keyword space to execute the ROS. So we will go on later on how does ROS works later on. Alright, so we go on to the SRC. So this is an example of a ROS package. Alright. For example, alright, this is all of the software codings to execute one specific task. So for example, if you want to execute both of these programming in C++ or all of it, it is applicable if you use ROS. So you just need to use the, for example, if I have it, this is okay. This is the, alright, this is the launch file that could actually execute all of those programmings. So it is alright. It is okay for you guys to execute multiple modules by using ROS. So I would like to stress out on this. The reason why you're using ROS. For example, if this coding is in C++ and then this coding is in Python, you could actually execute it at the same time by using ROS. So there is no need for you to actually convert all of this in C++ or convert all of this programming in Python. So that is where it is very useful for you guys to use ROS. Right. And also we go on to the third point, which is an advanced simulation capabilities with tools for testing and visualizations. For example, is the Gazebo and also the ROS software. We will see later on how we want to do the visualization. And there is also the communications between processes over multiple machines. The terms that we're going to use in ROS is the publisher and also the subscriber. So the connections between the other nodes or the requested services can be done by using the publisher and also the subscriber. Okay. Alright, this is a very unique point why you have to use ROS. Okay. So ROS is actually actively developed with a huge community. For example, alright, we'll go on to the wiki ROS. Okay. Alright, so this website is actually where all of the ROS developers are communicating with each other. So in case if you guys have a specific task and you guys have a problems in ROS, you could actually just click on the Q&A answers.ros.org. Alright, so you guys can see that there is a lot of questions or a lot of problems being published. So if you guys have any problems or any questions regarding ROS, you could just publish your questions and the other ROS developers will help you to solve the problem. So it is very useful. Everyone could try and help you to execute your task in ROS. Alright. Okay, so now we will go on to the robots that are fully developed by using ROS. So the first one is the Turtlebots by Willow Garage. And this Turtlebot, I highly encourage if you guys want to like have your own first learning by using a hardware, you guys could actually use the Turtlebots. It has the built-in ROS, so if you guys want to explore more about ROS, you guys can use this robot, or you guys can actually build your own ROS robot by using a Raspberry Pi. So it is very applicable, or you guys could actually build your own ROS. You build your own ROS robot, yes. And okay, and the second one is that we have the Husky unmanned ground vehicle, which is built by the ClearPath Robotics. And the last one, we have the Captor drone by Guytech. And you guys can have like another example, which is the Parrot drone. It also has a built-in ROS, which is the Bebop drone. So you guys could actually explore on how they actually execute ROS by execute ROS in their in real time for example for their specific tasks, like their movement, their taking off, their many types of tasks that they have. Okay. Alright. You guys can see from here we have several ROS versions. So you guys have to take note about this. For example, when you have a specific Ubuntu or Linux operating system installed on your laptop, you guys actually need to have a specific ROS version installed. So for example, if you have the Ubuntu 16.04, you guys need to install like the ROS Kinetic Game. So you guys can see this. This is the ROS Kinetic Game version, which is another type of ROS version. And there's a lot of many others ROS version, which is this ROS Melodic Morena, which is latest one, and then you have the ROS Lunar Loggerhead, and then ROS Kinetic Game. So ROS Melodic Morena is actually for the Ubuntu 18.04, but I highly recommend you guys to install the ROS Kinetic Game. Why is it so? It is because that some of the packages that is built by using the ROS Melodic Morena are not stable. So in order for you guys to have a stable package, a stable ROS package, I highly recommend for you guys to install the ROS Kinetic Game version. The last date for it to be available is like in 2021. Okay, it is next year. So then for now, if you guys have a ROS task to be built like for this year or maybe like next year, I highly recommend you guys to use ROS Kinetic Game because of the stable packages. But after that, after 2021, you guys can move on and use ROS Melodic Morena ROS version. Okay? Alright, so you guys are okay? I'm really totally sorry about that. Okay. Alright. Okay, now we have the overall of ROS. As you can see that the first one is, it is a middleware, which means that you can actually communicate between each other, and there is also the many types of other parameters that can be used by using ROS as a middleware. And also we have the robot specific features in ROS. For example, if you want to know the, for example, the standard robot messages that we use, and we also have the pose estimation, which is the position of the robot, localization, and also navigation. And all of this overview for such as the RVs we're going to see on later, the tools that we have in ROS, and also other integrated libraries such as the Gazebo, OpenCV, and etc. Okay. Alright. So if you guys have any problems for the connection, my team will try to help you guys. So I hope you guys will be patient for a while. Okay. Alright. Okay. For if you guys are into the old link, you can actually use the new link for the live stream, because we have changed the link because of the network connection. Oh yes. Alright, from Idris, what kind of hardware that can use to run ROS? Is it possible to run at Raspberry Pi? The answer is yes. You can actually use Raspberry Pi to execute ROS, but if you guys are using Raspberry Pi and you guys want to install ROS in the Raspberry Pi, there is like a specific way for you guys to do it. But don't worry, I will give you guys the link in a booklet so that I could guide you guys on how to do your own self-learning. Alright. So if you guys see here. Alright. So this is where you guys can install ROS. Don't worry, I'll give you guys the link later. Okay. So you can see if you guys installed Ubuntu in your laptop, you guys can click here, and then you just follow on all of the steps that are given in the website. But if you guys are actually using Raspberry Pi, there is like a specific way for you guys to install ROS. It is not exactly the same as the one that is shown in the website. So I'll give you guys the link later, and then you guys can explore more. Okay. Right. Alright, so now we go on to the example. This is the robot that we actually built at Robopreneur. This is the unmanned ground vehicle that is used for SLAM, which is the simultaneous localization and mapping. And this robot is running ROS by using the Nivea Jetson. And we installed the ROS in the Nivea Jetson, and then we have like a real sense camera which could give us the view from the robot in 1D, and then we also installed a 2D LiDAR on the robot. So we also use the ROS to actually execute a 3D mapping by combining the real sense camera and also the 2D LiDAR camera. So for example, is this one. As you guys can see, this is the Gazebo simulation, and on your left hand is the Gazebo simulation. On the right hand is actually the RVs. So as you guys can see, onto the Gazebo software, you have the real environment of the robot, and then in the RVs, this is where the robot is actually executing its task to scan the environment and to know what are the obstacles that are happening in its environment and what are actually visible in the environment. So this is where ROS is very useful for you guys to actually execute a specific task like this. So you guys can see as the robot actually move in real time in the real world, the visualization tools could also update you inside on in the software that we use later on. For example, the Gazebo and also the RVs software. Okay. Right. Alright, this is not a turtlebot, this is our costume made unmanned ground vehicle robot. So this is actually built by Robopreneur, Sendirian Berhad, so it is not a turtlebot. Yes. Alright. Okay. So as you guys can see from here, it is the same. Guys can see the Gazebo simulation and also the RV simulation, and you can see in the terminal where the position, the x-axis, also the y-axis of the robot is updated in real time. So we can see on the movement of the robot in real world and also in the simulation tools. So it is very useful for you guys. Okay. Alright, so now we'll go on. This is very important section for our learning today. So we'll go on to the key concepts that are being used in ROS. So before that, I would like you guys to actually understand these principles. Alright, as we go on, every program in ROS is called a node. Remember, node is very important in ROS. So every program in ROS is called a node. Okay, what do you mean by program? So what it exactly means by program is this coding. So this is what we call nodes in ROS. So every program here is nodes. Okay. So alright, so we go on to the next statement. It says that every independent task can be separated into nodes which communicate with each other through channels. Alright, so in those channels, we call it as topics. Alright, so you can see this is the nodes. Alright, and then if I open one of the coding, okay, this is an example. So here we include the specific library that we are going to use for this specific task, and it is very important for you guys to include the ROS inside the library ROS, the ROS library inside. And then you can see that from this coding, you have the broadcaster. Okay, hold on. Okay, we see this first, which is the ROS node. It is initialized. So you can see this ROS, it is initialized. So if you want to know what type, what is the ROS name, the ROS node name, you can see here This is the Gazebo node. Okay, this is the name of the node. And then, okay, each programs are nodes, and then you can see that it says that they communicate between each other by topics. Alright. As you can see, here is one example of topics, Autumn. So in order for the nodes to actually communicate between each other by using topics, it actually needs to write the specific name of the topics inside the coding. So this is actually how ROS works. So we'll go on and then we will see more examples for you guys to understand. Okay. Alright, this is the important concepts that we are going to use in ROS. Okay, we have the ROS masters, nodes, messages, topics, services, actions, and also message types. So we'll go on, we'll go through one by one. Okay. Alright, so this is the basic ROS architecture that is designed for you guys to understand better on how exactly ROS works. So as you guys can see, the first layer in ROS, it consists of a package, a ROS package. Alright. As I have said before, okay, we see from here, every ROS task or ROS packages need to be inside a cat keyword space. So on how you guys actually need to install this, I'll give you guys a specific link in a booklet so you guys can actually install this cat keyword space. Okay, so we go on to inside the cat keyword space, we will have a build file, devel file, and also SRC. So every ROS packages is located in the SRC. This is an example of a package. So this is the first layer of ROS. Then we'll go on to the second layer of ROS, which consists of the nodes. For example, you have a node that is written in C++, and then you have a second node that is written in JavaScript, and the third node is written in Python. So for this file, it is actually depend on your task, but the nodes that it is referring to is this one. This is the programming, or we call it in ROS, the nodes that are available in the second layer of ROS. So the third layer, it consists of the topics, and all of these topics is where the communication appear. So in order for the ROS node to actually communicate between each other, it needs to have the same name of the topic. Okay, I will recap back for our lesson on the ROS basic architecture. So the first layer, it consists of a package. So this is the first layer of ROS, and you can see from here, cat-kind workspace and SRC. This is a package. This is a ROS package. So every ROS package needs to be executed in a cat-kind workspace. This is the cat-kind workspace. Okay, go on. This is the cat-kind workspace. And this is the SRC file. This is automatically built for you when you install the cat-kind workspace. And here is where the ROS package is located. Okay, so we go on to the second layer of ROS. It consists of several multiple nodes, and it could be written in C++ or Python, or for example JavaScript. It doesn't matter which type of software programming you are comfortable with. And then the third layer we have is the topics. So in order for the topics to actually send data or transfer data or communicate between the nodes have to have the information or have the same name topic. For example, this is topic 2. And then if it wants to actually communicate with the third node, so you guys can see here is the topic 2. So these both topics need to have a very specific name in order for them to communicate. Alright. And then we can see the terms that we use here is publisher. For example, if the node 3 needs some data or some information regarding topic 2, the node 1 need to actually publish the topic first in order for the node tree to actually subscribe the topic to know more about the information that it has. Okay. So this is the basic ROS architecture. We'll go on later so that you guys could actually have more understanding about this ROS. Right. If you guys are with me, you could actually send some response on the chat box so I will know that you guys are okay with the connection. Alright. So we'll go on to the first key concept, which is the ROS nodes. So you know that nodes are actually the processes that is used to perform computations of these or the codings. So if a node is correctly configured in a ROS network, each node can actually use ROS to communicate with other nodes. So for example, you have a example of a ROS node, like for example the battery voltage level, the ROS node for controlling the wheel speeds and etc. It's up to you. It's up to you on whatever node type that you want to create. Okay. Okay. Leonardo is okay. Alright, I'll go on and proceed. So this is very important. The ROS master. So the ROS master is actually helps to aid the connections between multiple ROS nodes. And what do it exactly mean by ROS master is that, for example, I'll give you a vision about it. So ROS master, what we actually meant by ROS master is actually this. ROS call. Okay. So this means when you execute ROS call into your terminal, it means that you are ready to build some ROS tasks, or you are actually ready to help the nodes to communicate between each other. So I highly recommend for you guys, before you do any ROS projects or ROS tasks, you need to actually execute ROS call into your terminal so that it will observe the activities that are happening in the nodes, so that it will gather all of the informations that are happening in your ROS project. Okay, so close the terminal. So it has all of the information that regarding about the node that is running, for example the name, registration, and etc. And its role is to enable an individual ROS node to locate one another so that they could actually send or transfer the data between a specific node. So ROS master is very important in this task. So once the node has located each other, they can communicate between by using the peer-to-peer type of communication. So, alright. Okay. We'll go on to the ROS messages. So ROS messages is where the nodes can actually communicate with each other by passing the messages. It is in a form of data structure. So I'll have a visualization later on so you guys can see more on what exactly does ROS messages mean. So we see this is also important, which is the ROS topics. So each topic has a specific name, like I have said before, and each node must publish data to a ROS topic. So the data is visible to other ROS nodes so that the other nodes can subscribe the data from the topic. So remember the terms topics, publisher, and also subscriber. That is very important in ROS. So as you can see from here, in the terminal, for example, you guys can open your terminal and then you can execute ROS topic list -v, so you guys can know all of the topics that are available in ROS, that are actually available in ROS from that very moment. So you guys can see all of this. This is, for example, the published topics that we have, and then we can see, we can move on. This is also the subscribe topics. So when you execute the ROS topic list, you could actually know what type of topics that is being published and what type of topics are actually being subscribed from that very moment. So you can know what type of what is the nodes that are actually communicating at that very moment, so you will know what is exactly happening. Alright, this is the ROS, publish and subscribe. So a publisher is a node that actually creates a topic and publishes the messages, and a subscriber is actually a node where it subscribes. It wants to know, it wants to gain a message or a knowledge or an information from another node. So that is how exactly ROS works. Okay, we have an example here. So for example, if you have one ROS publisher and then it published the topic that it has, for example, it is the topic 1 and the message that is occurred is the standard messages / string. So in order for the other nodes to subscribe, this publisher need to publish the topic and then it can be distributed to other nodes that are subscribing it. So these subscribers could be multiple of nodes, many types of nodes that need the information. So this is actually how the communication works. So we go on to the first example we have here. Alright, for example, we have like 2 nodes, which is the first one is the voltage sensor node, and the second one is the charging node. And for example, this voltage sensor is advertising or publishing a specific topic, which is the battery level, to the ROS master. So the ROS master actually has all of the information about the activities that are occurring in the nodes. So when it's published, we have the battery level topic available. So when it is available, the other nodes, which is the charging node, will subscribe the same type of topics, which is the battery level, to the ROS master in order to get all of the informations that are available in this specific voltage sensor node. Okay, so now after it has subscribed the specific topic, which is the battery level, now the charging node can actually have all of the information regarding this specific topic. Okay, so we will go on to the second example so you guys can understand more about ROS. So the second example consists of 2 types of nodes. So the first one is the camera nodes. So for example, that node is actually help you guys to have a view on what the robot is actually seeing. So the second one is the image viewer node. So that one is like a node. For example, you want to use to view the image through your laptop, so you can actually execute the nodes. So the first thing that it needs to be done is the camera node needs to advertise or publish a specific topic, which is the images, to the ROS master. So as I said, ROS master has all of the information, so it is very important for you guys to go to your terminal and again ROS core. Before you guys do any ROS task or any ROS project, do execute your ROS master first, which is the ROS core. Okay, so as we go on, you can see after it has advertised or published the specific topic, so the topic is available for other nodes to actually subscribe the topic. So when the image viewer subscribe the topic, it can actually gain all of the informations that are available in the specific topic. Okay, alright, so we'll go on to the ROS services. So this is very important. It is like another communication method. As you guys had seen before, it is involving publisher and subscriber. So this is another communication method that we can use in ROS. So it uses the method whereby a request or a reply method is used. So it is not like the publisher and also the subscriber. It is like another communication method that we are going to use by using the ROS services. So the one specific thing that we need to know about these ROS services is that it is a one-time communication. So we'll see on later about what it means by one-time communication. So one node will act as the service provider, which has a service routine running, and a client node requests a service on the server. So the client node will wait for response, will wait for the response, from the server. So we know that when it waits, it takes time. So in order for it to actually execute the ROS services, it needs to go from the point A directly to point B. So this means that if you use the ROS services communication method, you guys have to wait for the process to be done first in order for you guys to get all of the information. So this is basically a communication method that takes time for you guys to actually have the feedback, but it is applicable if the task does not really need quick feedback from the activities that are actually involved in the ROS nodes. So we have like an example from here. We have the battery node, which is the client, and then the client actually requests, for example, the information about the service, which is the set LED. So it requests from the LED panel node, which is the server, regarding the information, and then the LED panel node need to actually respond to the service, and then the client will get the information. So this whole process, if you guys use the ROS services, so this whole process needs to completely done, then you will get the feedback. So this actually takes time, but you guys have like another method that you guys can use, which it is an alternate communication method, which is the ROS actions. So ROS action, it is usually used when it is difficult to use services because it is too long. For example, you have a very huge data or very huge information. So if you guys need to wait, then if you guys need to actually get it very quick, so it is not recommended for you guys to use the ROS services communication method. So ROS actions is probably more suitable for you guys to have an intermediate feedback. So in the ROS actions, it allows us to make a request, which is the goal, and also receive a response, which is the result. So the server can actually provide a feedback while it's servicing the request. So the client can cancel previously issued requests. So while the process is actually executed, for example, the process is not finished yet, and then you guys feel like it is not needed for you guys to actually have that information after that. So then you can actually just cancel the request, and it can be done in a short time. So you guys can see here is the example. You have the action client, which is the node, okay, another type of nodes, action client, and then we have the action server. So for example, the first node is requesting a topic about the goal, and then at the same time, when the process is not yet done, it can actually cancel the request or cancel the goal, or it can actually cancel all of the goals before the process is being done. And then this is also another example where the action server can actually publish the status, the state, the feedback, and also the result. So this is a communication method where it does not consume time. So you can use those three types of communication methods in ROS. So this is a unique key concept in ROS, which is the ROS Spec. So the ROS Spec actually store all of the information that is being sent between the topics. So in order for you guys to actually like view or know the information that is available in the topics, you guys could actually execute this ROS Spec record -A at your terminal. So for example, this is the ROS Spec record -A, so you guys can actually gain all of the information. And then this is the topics. This is all of the topics that are actually occurring in the ROS. So you guys can see, okay, for example, this one. So we used a CD back files, which is change directory in Linux. So you can go, it goes into the back files directory. And then you can see that we are actually running the back time. and then we execute the ROS topic, so we can get all of the informations that are actually occurring in the autumn topic. Okay, so if you guys are not really familiar with the, okay, we go on to this first. So this is the back files, so you can see that this is all of the topics, and then we can know that this is all of the messages or the information that occurred in the topics. So if you guys are not really familiar on how to use Ubuntu or Linux operating system, okay. Okay. For example, if you guys want to open a new terminal, you guys can key the Ctrl-Shift-C, Ctrl-Shift-T, so you guys can open a new terminal. Hold on. Okay. So that is the example that you guys can do. So for example, if you guys want to know the available files inside, you can use ls. Right, so you guys can see all of the files that are available in that directory. So for example, if I want to enter cat king workspace, so this cat king workspace, you can use the cd, so change directory, and then I just enter ca, and then I use the tab, and then it will automatically enter the it will automatically give you the name for the whole cat king workspace. So I'm entering the cat king workspace directory. So as I said before, if for example you want to know the files that are available inside, you just use ls list. Okay, so you can see that, for example, okay, here we are actually in the cat king workspace. So when I key in the list ls, so we can know the available files inside. So that is how actually Linux works. So you guys can explore more. Okay. So now we will go on to the ROS messages types that are available. This is the type of messages. If you are familiar with the programming, you guys will know that we used all of the integer, floating point, and etc. So okay, a ROS message is known as a field which consists of a type and a name. So if you guys are familiar, for example, int 32x or int 32 while, so this integer 32 is the field type, and x, for example, is the field name. So a ROS message can actually consist of a basic data types such as the floating point, integer, boolean, and etc. So this depends on you on what type of messages that you have. So this is also the same. The field types also consists of a standard data type used in messages, for example the integer 32 counter, and also you can make like a bespoke types that we create, for example sensor messages, /ranged, and also there is like a fixed one, a fixed field types, for example the float 32 ranges. So you guys, you can, this, I think if you guys are very familiar with the programming, any type of programming like C++ or Python and etc., this is actually the basic part where you can actually understand about the integer, the floating point, and etc. So I think it will be easy for you guys to understand these key concepts. Okay, this is the example, standard message type. Okay, you guys can see on later. So this is also the same. Alright, so now we will see on how exactly ROS works. So okay, we see now every program in ROS needs to be a part of a workspace. So like I have said before, okay, so the workspace that it actually meant is the cat king workspace, which is this workspace. So after you guys has actually installed a ROS, no matter what type of version you have, melodic version or kinetic version, So it is compulsory for you guys to actually install this workspace. Don't worry, I'll give you guys the link later in the booklet so you guys can have your own practical self-learning later on. Okay. So this is the steps that you need to do in order for you to install or create your own Catkin workspace. And it is very important for you guys to take a note here. So whenever you click this, it actually selects the ROS version that you have. So make sure that you are not mistaken and you use these specific steps for your own ROS version. Okay. So okay, this is very important. Whenever you have already created a Catkin workspace or any types of ROS packages, okay, maybe I should give like an example. Create package ROS. Okay. This is very important. You guys need to take note of this. Okay, this is where you can actually create your own Catkin package or like a ROS package. It is very important for you guys to actually in the Catkin workspace src directory. So for example, if I opened my terminal, remember ROS core. Okay, ROS core is launched, so it started to collect all of the informations. And then I click on the Ctrl-Shift-T to open a new terminal, or you guys can just new terminal here. Alright, so I need to enter the Catkin workspace tab, and then I'm entering the Catkin workspace, and then I also cd change directory into the src. Okay, so whenever you guys wanted to create a new ROS package, make sure that you guys are creating it inside this directory. So for example, if I want to create a new package, this is where it begins. Catkin create package. This is the name of the package, and this is all of the things that you want to have in your package, such as the standard messages, the ROS-Py, or ROS-Py stands for ROS Python, and then ROS CPP, which is the ROS C++. So in order for you guys to execute it in ROS Python, so you guys need to have this ROS-Py. And then if you want to execute it in C++, you guys need to have this ROS CPP. So for example, if I just copy this one, and then I like Ctrl-Shift-V. So you guys cannot like Ctrl-V in order for you guys to paste it. You need to like key or click on Ctrl-Shift-V in the terminal so you can paste the information. That is how Linux works. So for example, if I wanted to change it, make it. Okay, for example, this is the things that you need to execute. For example, the ROS package, I will change it to ROS learner. Okay, this is the name of the ROS package, and then I want to insert it like the ROS CPP ROS Py. Okay, just that. So I click enter. Okay, it is created. But remember, after you have created or the ROS package, you need to like go to the Catkin workspace directory and then Catkin make. So remember, every time that you changed the or you make a new ROS package, execute Catkin make, so that you will go on through on the new package. And then after you have done it, remember it is in the Catkin workspace. You need to source level /setup.bash. Those are the two things that are very important after you have created a new package. So it is very useful for you guys to have this information So whenever you have an error after you have created a package, those two types of instructions are very useful. So you can troubleshoot the problem. For example, you have a problem, and then you can just execute those both instructions so that you can helpfully solve the problem that you have. Okay. Okay, during installation, what happens if I accidentally miss a step? Can I go back and just do the step, or should I restart the whole process? If you actually miss a step, and then it is okay if you want to go back and just do the steps that you missed, and then you need to actually just to avoid any errors, for example. Okay, for example, you have already maybe like need another example. Probably need this one. Okay, maybe for example, if you, for example, okay, you have done this source, this instruction, this command, and then you for example, you forgot to do the next step. So it's okay for you just to go on here, and then you need to actually repeat back all of these commands that are available after that. Okay, so it is better for you to do that, because if it is not actually, it depends on the commands that you are doing, but just to avoid such errors that are not very applicable, so it's better for you to just redo the step and then go on back to the next steps. Okay. Alright, so okay, we'll go on to this. So we'll go on, every workspace further contains packages. So you guys can see here, this is the workspace, and then we go on to the SRC, and here you can see the package that we have created, ROS Learner. So this is the new package. So when you enter the new package, you can see that all of these include SRC and also the CMake list, and also package is automatically being installed into your file. Okay, and then you need to know that there are packages that are isolated blocks of codes containing one or more nodes. This is depending on you guys on how you want to create your package specifically. So then we have the common ROS tools, which is the ROS core, ROS CD, ROS range, and ROS run, and also the ROS launch. So what is the difference between ROS run and also ROS launch? So specifically, ROS run is only to execute only one type of programming, but when we use the ROS launch, you can actually execute, for example, okay, for example, only for this type you could actually use ROS run, but when you want to actually execute all of this programming, you need to use ROS launch. So when you want to use the ROS launch, you actually need to create a launch file. So we will not go on through, because this is more onto practical way. You guys can see later on. I'll give you guys the link for your own self-learning on how actually to write the ROS launch file. So this is how the nodes communicate between each other. Okay. Alright. So we will go on to section 4, which is the example of the ROS application. I'll give you guys a video. Hold on. Okay.
This is our UGV robot.
Okay, this is the example of our UGV robot. So you can see this is the real robot, and then we're actually executing the simulation or the visualization on what is happening in the robot. So we use the ROS run Telio twist keyboard to control the robot in the real world.
It is a keyboard to control the movement of the robot.
Okay,
For example,
we we see we use ROS run.
So this is the
Okay,
keyboard
this is
that
all
we
of the
use
instructions on
control
how
the
to control the robot. And then for example, if I key in any keyboards for that, any the selected keyboards, okay, I could actually like control the movement of the robot, as you guys can see here. So while the robot is moving, you can actually use the Gazebo and also ROS simulation to know on how the movement is really look like. So I could give you guys a better video so for you guys could see. Okay.
this is the terminal, for example.
So this is another video. It is the same. We ROS run the keyboard till your twist keyboard, and then
For example, if I want it to go backward, this is the position of the robot.
if I select or key in any of the keyboard, for example, so you can see that the simulation is actually moving.
So for example, if I want it to go to the left,
So while the real robot is actually moving, this is crazy. This is like turning around. So while the real robot is actually turning around, you could actually visualize it by using the ROS and also the Gazebo simulation. So in real time, all of the movements, all of the things that are visualized in the robot could actually be viewed by using ROS. So this is the beneficial of using ROS. So there is a lot of things that you can do. You guys can see through the YouTube's videos, there are many types of other things. For example, you can do like navigation, mapping, and etc. So it is very beneficial for you guys to use ROS. Okay. Connection. Okay. Alright. So we will go on onto the last section, which is the section 5, which involves the debugging and also the visualization tools. So this is more into a practical section. So we can see, okay, the first thing that we are going to do is we're going to see the ROS, which is the 3D visualization tools. It captures and also visualizes the data that is being published in ROS. For example, if you want to know the TF, the transform form of the ROS, and etc., you can use the ROS. Okay, so for example, okay, this is actually what I meant by using the ROS tool. Okay, okay, what is the minimum spec for the PC in order to run ROS? Basically, it depends on the how many gigabytes that you have. So if I highly recommend for you guys to have like 200 gigabytes for your memory for Ubuntu Linux operating system. That is actually enough. 150 until 200 gigabytes, so that is enough for you to execute ROS. So okay, so you can see from here, this is okay, for the specs. For example, if the laptop is quite slow, I recommend you guys to use the SSD, install the SSD, so that you can actually execute in a better way. So it depends on how many. Okay, it depends. Alright, okay, so now we go on to the ROS. This is the simulation. So for example, if I have any robot, for example, I can just make it visible here, and I can add, for example, the camera that are available at the robot, so I can actually view on what the robot is actually seeing. And other than that, you can actually have the depth cloud and also the position of the robot and also the TF. This is the transfer form of the robot, so you can actually just insert it and make it available here. So this is the use of having ROS simulation. So in order for you to close the ROS simulation, you can go to the terminal Control C. So that is when how we execute it. Okay. So now we'll go on to the next example that we have. So we have the example. This is the TurtleSim simulation. So we can go on through and see how exactly ROS work by executing this TurtleSim. So I highly recommend you guys, for example, okay, we'll go and do it again. Okay, I want to open a new terminal. Okay, ROS score. Remember, you need to execute the ROS score. And then, for example, if I want to open a new terminal, I open a new terminal and then sudo. Okay, this really takes time. If I do the sudo apt get update, it is usually to update all of the files that you have in your ROS. So it is better for you to get update every time you want to execute a new ROS package, for example. But because it takes time, I will not do this this part. Okay, this part I will not go on through this. And then if you guys have your own Linux, you can actually go to this sudo apt get install. This is where you can install the package that are already available in the website. So control. Okay. Oh, is there any specific video card VGA spec for run the visualization tools? No, there is no specific video cards. Okay, can I recap? Alright, I can recap. Okay, so for now, we are in the section 5. I'm very sorry. We are in section 5, which involves the debugging and also the visualization tools. So we'll go on to the first visualization tools, which is the RVs. So it is a 3D visualization tools, and it captures and also visualizes the data that is being published in ROS. So in order for you to actually execute this RVs tool, you can go on to your terminal, open a new terminal, and then ROS run RVs. Okay. So now you can have your RVs tool. Then, for example, if you have any robots, real world robots, and then you can just add the camera so you can view whatever the robot is viewing, and then you can have the any types of things details that you want. For example, you can have the transfer form of the robot, and then you can have, this is very good, the marker, so that you can know actually the movements of the robot and etc. So you can have all of this data information about this. So you can use RVs to have all those information. Okay. So in order for me to close the RVs, I can just click on Control C. Alright, so the close down the RVs simulation tool. Alright. Okay. So now we will go on to the practical part, where we will see how TurtleSim actually works in the simulation. So I highly recommend for you guys to do sudo apt update every time you want to execute a new ROS package and etc. so that it will actually update all of the packages that you have. And then in order for you guys to install, I do clear. Okay. Sorry. Here. Okay. So in order for me to install this package is available in the website. So you guys, I'll give you the link in the booklet so you guys can actually install it yourself. So this is the command for you guys to actually install it. So you guys can see Control Shift V. Remember, every time you want to paste something, Control Shift V. Okay. So it asks for the password. So this is very important in Linux. Whenever you enter the password in the terminal, you could not actually see it. So it is not visible. So I have already entered the password, but it is not visible in the terminal. So because I have already installed the package, so it says 0 upgraded, 0 newly installed. Okay. So next we will go on to ROS launch. ROS launch, where you actually launch the package. Okay, for example, I Control C and then Control Shift V on the terminal. Okay, this is our turtle sim. So you can see that we have a turtle sim, and it says that here use arrow keys to move the turtle. So in order for me to move the turtle, I need to click on the terminal and use the key. So I'm actually controlling the turtle, and another turtle actually is following. So whenever I for example, I click on this and then I use the arrow key to control it, it's not moving. So when you want to control your control the turtle using the keyboard, you need to actually click on the terminal and then control it. So that is how you can use the keyboard to control your turtle sim. Okay. Alright, we move on. So in order for me to ROS run this RQT graph, you will see what is the usage of having this RQT graph. Control Shift T. Control Shift T. I open a new terminal, and then I just basically copy this command. Okay, Control C, and then Control Shift V. So we will see what is the use of this RQT. Next, we will see on how RQT could actually give us a very good information. Okay, this is the RQT graph. So for example, I have executed the turtle sim package, and it's available now, and then I ROS run the RQT graph, so I can see how the communication actually works in the ROS package. So for example, if I have the first turtle one, which is the turtle that I'm controlling. So okay, turtle C. Okay, you can actually see that both of these turtle 1 and also turtle 2 is actually communicating between each other. So in order for me to actually control the movement, I can use the teleop, and then I can use the turtle 1 CMD velocity to control the movement of the first turtle. So this is the ROS master, the ROS code, where it has all of the information regarding the nodes available, regarding the topics that are available. And then you can see that after I have published the topic, and then you can actually control the first turtle, and then the second turtle could actually follow the movements from the first turtle 1 TF broadcaster. So you can actually know what is exactly going on in the ROS package that you have by using the RQT graph. Okay, so in order for me to close it, Control C, it closes by itself. Alright, so next we will go on to ROS run RVs. Like I have done before, I opened the RVs. So ROS run RVs. Okay, we open the RVs. Okay, now we will see on how RVs actually simulates the total movement. Control Shift T, open a new terminal, and then we execute this ROS run turtle sim. This is the ROS package name, and then you can see Control Shift V. Okay, it says use the keys to move the turtle. Okay, I open. Okay, I opened it and for example, I enter the TF. Okay. The world. Alright, so now we can see that. Maybe we can go a little closer. This is the world TF. And then guys can see this is the both turtles that we have. So imagine that you are actually controlling your real robot by using this. This is, imagine that the turtle sim is your real robot. And then I use the key. I click on the terminal and then I use the keyboard to move the turtle. Okay. Okay, it's not very clear. So you guys can actually see that I'm actually controlling the movements of the turtles in the RVs. Okay, kalau melodic just tukar kinetic tu jadi melodic je kan. Okay, for example, if you have this package in for example in kinetic, then you want to install for your version, yes, you can just select any like the kinetic word and then you just change it to melodic. That is possible, yes, you can do it. Okay, so that is exactly how you control your, for example, this is the turtle sim by using the RVs, and this is also how you could actually control your robot in the simulation tools. Okay, so Control C, I close it, Control C, Control C. Okay, so it is closed. And also this one, Control C. Okay, so maybe I want to clear. Okay, clear everything. So this is how you use RV's simulation tool, and then we will go on to this Gazebo Simulator. So Gazebo is an open source 3D robotics simulator that supports code for sensor simulation and actuator control. And this is already, you have like lots of robot simulations that you can do in Gazebo. Then and they are available in the website, such as the Now Humanoid. You can use it to simulate, and then you can also like have a readily sensor plugins such as the cameras, the lidars, IMU, and etc. So I'll give you guys a video on how actually Gazebo works. Okay, we have an example here. Okay, in the next slide, where we are actually controlling the drone by using the Gazebo simulation. Okay, so this is the video. I'm opening a terminal, a new terminal. So I use ROS call every time you want to execute something. It is recommended for you to execute the ROS call first. So every instruction step by steps are available in the slides. I'll give to you guys later. So this is one of the ROS launch, a ROS launch that we have, for example. Okay, let's see first. Okay, this is the Gazebo simulation. Okay, now you guys can see the simulation in the Gazebo. You can see now that we have the drone in the Gazebo simulation, and I open a new terminal in order for me to control the movement of the drone. So that is where I publish a new topic, which is takeoff. So you can see the drone is actually taking off. So this is very good, very useful for you guys to have Gazebo simulation. Okay, now I run the Teleop twist keyboard in order to control the movement of the drone forward, backward, and etc. So now you remember when I said where you want to use the keyboard, remember to click the terminal first and then click on the keyboard, for example I, K, J, L, to control the movements of the drone. Okay. So that's is basically it on how you want to control the movement for the drone. So, okay. So this is all of the instructions or the commands that you can use to actually have the Gazebo simulation yourself, to have the drone Gazebo simulation. So later on, if you have installed your Linux and also your ROS, you can actually execute all of the steps. Okay. So now we will go on onto our last section, which involves the debugging tool in ROS. So in order for you guys to use this debugging tool, it is actually to inspect a running system whenever there is like a problem or any things that look suspicious, so you can actually execute the command in your terminal. Okay, so for example ROS WTF, like this, so you can know if there is any specific error. For example this, yes, error could not contact the following nodes sim. So you for example, if in your simulations you have any troubles, you cannot execute, so you can use ROS WTF to configure out what is exactly the problem. So this ROS WTF is very useful. Okay. So basically that is for our basic ROS online training. So if you guys have any questions or any inquiries regarding the topics that we have discussed, you guys can use the chat session so that now I can actually view all of the questions that you have. Or any recommendation, for example, yes, I'm very sorry, I'm deeply sorry about our Wi-Fi connection, so we will improve again in our next training online. I wish you guys all stay safe. So if you guys have anything questions, you can just email to me. I will directly go to you. Stay safe, keep on exploring, and thank you very much. And happy fasting. Goodbye.